Alright guys, let's solve the last question. This is example 5.13. The lever ABC is pin supported at point A and member BD. So you may have to realize that the member BD is two-force member. Why? Because this is a stable object and there are two unknown forces at point B and point D respectively. So there are two unknowns for Bx, By and Dx, Dy, but the force acting on the force B and the force D is has the same magnitude. They have the same magnitude. They have opposite directions, and they are all acting on the same line. And you can see that we don't know the direction of force A, but since this object is stable, that means we have one external forces, this right hand directions. This is the intersecting point. So the force A should be crossed at the same point. Let's say this is point O. So that means this is the three force members. The question is determine the force of the pin on the lever A. So what is the support reactions at point A? Let's look at the problem here. We can set the orientation like this is positive X, positive Y. Control that. Oh, my drawing is really bad. 0.2 meter. And this distance 8. When you solve the problem, please draw the free body diagram first, so that I can give you the partial credit. So we know that there is a force and there's another force. Let's draw the another one. Another color. There is another color. Never mind. This. Okay. Okay. Force B, force D. These guys is two force members. They are stable. They have the same they have the same magnitude, opposite directions, acting on the same line. Oops. Okay. And okay, this is an intersecting point. And there is another force F A. like I said, direction is not important, guys. In this case, once we figure out the numbers, and we can determine the direction of the unknown forces based on the sign of the values. Okay, if there is a negative sign, then our assumption was wrong, so we can change the opposite directions. Okay. So since the question is what is the force A, and we don't need to think about the force D because this is one object, so that wait a minute. I guess this angle is 45, right? This is 45 degree, so this angle should be 45 degree. And that means if you look at the dimension here, the dimension here is 0.5 meter. Then this dimension should be 0.5 meter. This is 45. This is 90. How about this angle? So we can find that angle theta is equal to, you know what? We know this dimension and this dimension. This one should be 0.5 minus 0.1. Here we have 0.1. And how about the vertical distance? We have a 0.2, 0.5, so the vertical distance is 0.7. So theta is inverse tangent 0.7 divided by 0.4. So theta is equal to theta is 60.3 degree. So let's solve the problem using the equation of equilibrium. Since we have two unknowns, force A, force B, and we can just use the two equations. Let's use sigma fx equals 0, sigma fy is equal to 0. So for the x-axis directions, we know that there are 400 Newton. And we have a force A, let's say just A cosine 60.3. How about the B? We have a negative direction, B cosine 45 equal to 0. How about the vertical direction, Fy? We have A sine 60.3 minus B sine 45. This one should be equal to 0. So we have two equations and we have two unknowns. You can solve the problem. So A is 1072 Newton, B is equal to 17 Newton. So this is the answers. Here is a short announcement. Next Tuesday, which is April 7th at 11 a.m., which is our regular class hours, we will have an online quiz. It's a 30-minute quiz, 30 points, and this is open book and open notes. You need a calculator. We will cover the all chapter 5, chapter 5.1 through 5.5, equilibrium in 3 dimensions. So I will announce this on the Blackboard as well. So don't forget to join the Blackboard on Tuesday at 11 a.m. April 7th and complete your work within 30 minutes and submit your work, your solving process through the link if you want to get a partial credit. Okay. All right. Thanks for watching this short video. Have a great day.